This is the beginning of Project 4, and in Project 4 what we're going to do is we're going to actually run our regression results and test some series of assumptions related to linear regression, the best linear unbiased estimate assumptions. And so to do that we just need to run some regressions, but before I do that I'm going to go back and fix a problem that I did in Project 3. When we put Project 3 together, I talked to you about orienting your variables in such a way that you got positive parameter results. And so if we go back and we look at the instructions, for the campaign finance report reform bill, we had Democrats as, I coded them as 1 and Republicans as 0 because Democrats generally favored campaign finance reform more than Republicans. In order to kind of match up the ideological preferences to that, I had to multiply the nominate scores, the first dimension scores, by -1. And so that created the Democrats up here as positive values and the Republicans down here as negative values. Again, we created that positive slope parameter. Now, originally, I thought that the two continuums, the second dimension scores, were reversed, but upon looking at it a little bit closer, I found out that actually if you invert the first dimension scores, you should actually invert the second dimension scores as well. So notice that I didn't multiply these by -1, and that would have put like the Democrats over here and Republicans over here. So instead I got that kind of downward sloping estimate. And so one thing I'm going to do really quickly is I'm going to do that calculation of the inversion, and then I'll have my 3 variables for which to run my regression results. Okay, so this isn't very hard at all. We're going to do some of the same steps we did last time, and all I'm going to do is I have my first dimension score, my negative score, so I multiplied that by 2. Notice here I've got party ID as 1s, and those are going to be those are now going to be positive, so those are the Democrats. And all I'm going to do is take the second dimension and create this second dimension negative score. So let's do that really quickly. We go up and click on this, which gives me the SPSS. I'm going to transform compute variable. I'm just going to call this DWNOM to negative, just like I did the other ones. And all I'll do is just take this one and multiply by -1. And so we inverted it, and we'll have consistent results. If we want to see this, we can now just do a quick plot. I'll go up here, graphs, legacy design, scatters. And if I go to our dependent variable, which is our vote score, and I take my x variable, remember always put your dependent variable on the y, your independent on the x. That's generally how we do things. And if we do that, now we'll end up getting, we should click on this really quick, and then I'll just options, I'll have it insert the fit line. And it's not a strong fit here, but it may be significant after we control for the other one. And so we want to get that positive result. And actually, we just want to make sure that the Democrats and Republicans are all kind of oriented in the same way. So that's the first thing that we needed to do. We've got kind of the variables ready. All we need to do now is just run some simple regression results. And so before I do that, we're going to be turning in some of this results, and I don't really need this information in here, so I'm going to select on all that. I'm going to go up to edit, and I'm going to delete, and that'll give me a fresh start here whenever I start running my regressions. Okay, good. All right, so the first thing, I'm going to pause and make sure I get this correct. Okay, so at this point I'm ready to run my first regression. I've got my dependent variable vote score. I've got a party identification of 0 to 1, 0 for Republicans, 1s are Democrats. That will give me a positive parameter result. In order to orient my nominate scores in the proper direction, I had to multiply those by -1. Again, Democrats supported this bill more than Republicans did, and so I should anticipate that inverting this will give me that positive parameter. And I just fixed the second dimension that I didn't invert previously. And so I am now ready to run my first regression. Okay, so let's do that. It's really simple. It's not very hard. Let's go to regression. Go down to the linear tab, and then it's going to ask you a couple different things. The first thing that we need to do is designate our dependent variable. Here we're going to use vote score. Our independent variable, I'm going to use party identification. We're not doing really complex models here. We're just running some models to show you how to do things and learn how to do some simple regressions. I'm going to ask it to run a couple plots for me. And these are going to be useful to testing the best linear unbiased estimate residuals and see if they match up to assumptions. And so the first thing I'm going to do is I'm going to do the z residual, and I'm going to plot the standardized residual, that means the z-score for the residual, on the y-axis, and then I'm going to put the dependent variable on the x-axis, and so that's going to give me my first plot. The second plot that I want is the histogram, and I'm going to use that to test the homogeneity assumption as well. Okay, so we've got the plots established. The final thing that I want to do is I want to save some residual patterns, residual values, because I'm going to also take a look at those, or I may need them to run some correlations, and I may run a quick test for normality on that. So standardize, I'm going to click on that and continue. Okay, so this is my first regression. I've got a dependent variable of vote score, and I'm going to predict that just on the basis of party identification, where party identification label 1 is Democrats and the null configuration of 0 is Republicans. I'm going to ask it to run a plot of the standardized residuals versus the dependent variable and give me a histogram of the standardized residuals. And then finally, I'm going to ask it to save the standardized residuals as well. Okay, so everything's good and ready to go. Let's run it and see what happens. Okay, so this is what the regression output looks like. First thing you'll notice is this tells you the variables. We did party identification, and it says the dependent variable is vote score here. So we did vote score on party ID. You'll know that because when you go down here, you'll see the independent variable should be right here. Okay, the model summary is this. This is the R-square value, and this is the adjusted R-square value. And so we are going to use the adjusted R-square, and that tells us how much of the variance in the dependent variable we can explain with our model specification. Here we could explain a lot. 0.79 is very much. It maximizes at 100. So we explained a lot of the variance and support for this bill on the basis of party identification. Okay. The ANOVA is sort of a couple of things that you can get here. Is you can get the degrees of freedom. That's nice because it tells you what the degrees of freedom for your analysis is. The F-score just tells you whether the model as a whole is significant, and we know that it is, but if you have an R-square of 0.79, the model is significant. Down here is the constant value. That is your beta. That is your standard error associated with the beta. This is your t-score, and this is the significance level. So we have a constant. Constants doesn't really matter if they're significant or not. It's nice if it is, but we don't have a hypothesis associated with the constant value. We do have a hypothesis associated with our independent variable, and here we have 0.74 or 74.1 is going to be our parameter size. The standard error versus that is really small if you look at it. Right? So 74 and a very small standard error, that gets us a t-score of 39, which is humongous, it's gigantic, and so that is significant at a very high level. So we are 99.9% sure that party identification is related to support for our bill. So we would be able to reject the null hypothesis, thus creating support for the alternative hypothesis that party identification is a matter here. Okay. These are the residual statistics. This is nice to have. We're going to show the standardized residual. The mean value is 0. That is one of the things that we need for our homogeneity test. Notice here that n is 433. Up here, the degrees of freedom is 432. It controls for the number of control variables, right? And so we have one control variable in here, so we have degrees of freedom of 432. Okay. Then you're going to see this is the plot for the histograms. Notice this isn't a really good normal distribution here, and that's because we have a really blunt dichotomous variable. So this probably isn't going to meet our histogram. This probably isn't going to meet our homogeneity test. And notice here we get a little bit of clumping. With dichotomous variables, we get these lines like this. We get these plots that go in the slope associated with the parameter. And if we're getting clumping, we'll see a lot of clumping down here and a lot of clumping, up here. And so that tells me we don't really have a homogeneous residual pattern. What that means is we don't have enough control variables in the model specification to completely tease out all the systematic effects. We know that because we only have one variable. But for this case, we'll use just kind of this simple standardized regression. Okay, that's good. We're going to do a couple other things here. I'm going to run all the other models, but we'll stop here and pick up with this in just a minute.